Hey students, I thought I'd make a video that hopefully will help the lecture. It is on relativity, and if you recall the beginning of my lecture, I said if you haven't been exposed to this, you're in for some real treats. There's just some really interesting, and you might even call bizarre, conclusions like time dilation and length contraction. But one of the challenging one here is adding velocities together and finding out what is the speed as one observer compared to the other. And in fact, that's why we call it relativity here. And your author's done a pretty good job here of giving you these two pictures side by side, but he falls short on something that I want to expand on. Let me start with your author here, because one of the challenges might be keeping straight the three different speeds. And I want to emphasize that. I hope you see three different speeds here. And look at this first picture. Let's call the snowball the object. And then we have the two observers. We've got the boy observing the snowball, and then we've got the girl observing the snowball. Now, I know there's a man in the picture, but he's moving along with the girl. And so that might actually be confusing. I hope not. Let me just cross out the man, because whatever the man sees, the girl sees. Those aren't two different observers. They're each moving along together as a group. Okay? And that's what these three different speeds are. This first speed, u, is the speed as seen by one of the observers. And the u prime is the speed by the other observer. Okay. Now, sometimes the beginning student will stress about which one is the u and which one is the u prime. And that's where I want this video to go. I want to emphasize it does not matter. Okay. We often like to think of the u as being ourselves, and we call that stationary. But the truth is, there is no such thing as stationary. I mean, you might have a natural leaning towards saying, well, the boy is standing on the snow and the snow is on the earth, and therefore the boy is the one not moving, and clearly the girl is moving across the sled. She's the one that's moving. And I would agree that's your natural case, but you're focusing on the earth, and the earth is spinning, and the earth is rotating, and the solar system is rotating around the Milky Way galaxy, and the Milky Way galaxy is expanding. So there is so much other motion going on, you cannot honestly say that this person is stationary. There is no stationary, but when you only focus on these three things, maybe I'll use the word stationary. I'll put it in air quotes, stationary, okay? And that's kind of the thing to do. I call it more of the reference point. So pick the reference observer, okay? So this boy is going to be my reference observer. And since the u represents the speed of the object, which is the snowball, from the reference observer, this is saying that the snowball is approaching this reference observer at 2.5. It also is saying it's moving to the right, so it's positive. Okay, now the u prime is the speed of the snowball as seen by the other observer. Sometimes we call that the moving observer. I'd probably better call the non-reference observer. Okay, so the non-reference observer, the moving observer, looks over and sees the snowball, and in this case, she throws it at a speed of 1.5, and she throws it to the right, so it's a positive. And then the v has nothing to do with the object. The v is the velocity of the two observers, and as measured from the reference observer. If you want to call it stationary, fine. So the speed of the stationary observer from the moving observer, or I like the reference observer to the non-reference observer. And you can see that the girl on the sled is approaching the boy at a speed of 1.0, and it's going to the right as seen by the boy. And so the boy is saying that would be the speed, okay? And I'll call this scenario number 1. I'm going to come back to it. Now, I'll deal with this second picture for just a second, but that's not what I want to really focus this video. The author's picture has this to kind of help you with your signs, and he doesn't really change the reference observer. In other words, the object in this picture down here is still the snowball, so I'll put here object. And the author still uses the boy as the reference or the stationary observer and the girl as the moving observer or the non-reference one. The only difference is they throw the snowball in the other direction. And that's an important lesson too. So that's why I thought I would address it before I move on to what I really want to say. But in this case, we would do something like this. Maybe I'll start with the u prime. That's the speed of the object, which is the snowball, as seen by the girl, the moving or non-reference observer. And since she throws it the other way, it's a negative 1.5. Okay. And then, and this one is a little trickier to observe, but from the boy's perspective, what's the snowball? That's what the u means. What's the speed of the object as seen by the non-moving or the reference observer? And so it kind of looks like the girl throws it from her sled at negative 1.5, but from the boy's perspective, she's moving this way at 1. So really the snowball is only going at a negative 0.5 from the boy's point of view. So that would be the value of u, and then again, notice it's negative. But the girl is still approaching the boy. And so remember, the v is the speed between the two observers, as seen by the reference observer or the stationary observer. So the girl is 1.0, and it's still positive. The girl's still moving towards the boy, moving towards the right from the boy's perspective. And so this would be the values of u prime, and v in the second picture. But in both of these cases, we are still using the boy as the reference, the u, the girl as the moving observer, and the snowball as the object. And there's nothing wrong with that, but I thought I'd point that out and just cross it out, and that's great. What I want to do is I want to address a question that I have been getting and often do get, is which one of the two observers is the u and the u prime? And I want to emphasize it does not matter. In fact, I'll even go one step further. It doesn't even matter which one is the object. Watch. Let me cross out the second picture. Let's come back to the first picture and let's look at scenario number 2. In scenario number 2, why don't I do this? I'll still call the object as the snowball, but let me take the girl as my reference observer, the stationary observer, if you will, the one that you want to measure everything from, the one that you kind of picture in the problem as being you. And so that means the moving observer is the boy. So I like to put a little r here for reference and a little nr for non-reference. So I still have the same observers and the same object, so I haven't switched it by much, but let's talk about the u prime, and the v. All right, so the u is the speed of the object as seen by the reference person. So in this scenario, it would be the speed of the object, the snowball, as seen by the girl, which is a plus 1.5. If you can imagine yourself being on the sled with the girl, the snowball would be going away from you to the right at a speed of 1.5. So that is what the u would become. And the u prime would then be the speed of the snowball, the object, as seen by the non-reference person. So then the boy here would be seeing this snowball at a positive direction of 2.5. Now, the v is the velocity of the two observers, but as seen by the reference person. So this one might be a little hard to imagine, but from the girl's perspective, she sees the boy approaching her, and so therefore negative, going, to the left at a speed of 1.5. Now you might say, no, come on, the boy's on the snow, and it's easy to kind of see that the girl's moving across the snow. But from this perspective, you might say, okay, I'm just sitting here on the sled, and what happens is the whole snowpack and the earth and the boy who's on the earth are moving towards me, and so they have a negative. And so that would work also. In fact, let me, before I get to like a scenario number 3, just put down this equation. Here is the mathematical equation that connects the 3 speeds together. And if, well, let me leave that equation up there and go. If we apply this to scenario number 1, our u is 2.5. And the numerator then becomes 1.0 plus 1.5 divided by 1 plus, and then we're going to have a 1 and a 1.5, then a ginormous number down here when we square it. So it becomes 2.5 in the numerator, and we've got like 1.000000000. Excuse me, and then that is just 2.5. So notice it does match. The equation does work for scenario number 1. But it also works for scenario number 2, and that's what I want to emphasize. That's why I got to keep saying here, don't spend much time stressing about which one is the reference observer and which one is the non-reference, or for that matter, which one is the object. It just doesn't matter. Some are more natural and easier to see, but I mean, and so, you know, I kind of think scenario number 1 is kind of the natural way that you would do it. You would kind of think it's the girl as moving, and they're each focusing on the object, the snowball. But this one does work. Even though you're still focusing on the snowball as the object, that kind of makes sense. But you're thinking as the earth and the snowpack and the boy as moving and the girl as stationary. But let me show you that it works. Okay, so if I go to apply this equation, the u, in scenario number 2, this would be 1.5. And the other side of the equation would be a v plus u prime. So v is negative 1.0. And u prime is a 2.5, and the bottom is 1 plus, and then we've got a v, which is a negative 1, and then a u prime, which is a 2.5, and then a ginormous number here. And so the top becomes 1.5, and the bottom becomes just a small hair under 1, which has more decimals than I can really put. But notice it's 1.5. So it does work. And scenario number, 1 and 2 each work. We could also do a lot more scenarios. And I'm not sure how many to do to emphasize my point. But let me do, I'll call it scenario number 3, where we do something, I'll call it kind of weird. Let me cross out my references here. Why don't we call the object the boy? And so the 2 moving observers are the snowball and the girl. The girl and the snowball are looking at the boy moving, which I know it's kind of weird because, obviously the natural place is to think of the 2 people watching the snowball. But, if this was like a spaceship or something, there could be a person inside of it, and so this might come up. Anyways, so I'm going to do this approach and show you that it still works. This is why it doesn't matter which one is the moving observer, which one is the stationary observer, or which one is the object. They all work. You just might want to pick the easiest one to either understand or to calculate. Okay, now, all right, so let me try this one. This will be kind of weird, but it works. Let me do the observer as the boy. And so why don't I take the girl as my reference observer, and then the snowball as my non-reference observer. Okay, and then let's talk then about the u prime, and the v. Okay, so the u is the speed of the object as seen by the reference. So in this weird scenario, this would be how fast is the boy moving as seen by the reference, the girl. Because remember, the boy is the object. And that then, as we talked about earlier, is also kind of hard to conceptually visualize. You got to kind of imagine the girl being stationary, and what happens is the boy and the snowpack and the earth are all moving towards the girl, so it's moving in the negative direction at a speed of 1.0, where, like the picture shows, you really kind of think of the boy as being stationary and the girl's moving towards the boy. But so this would, from that perspective, it would be the opposite. The boy is moving towards the girl, so it's moving to the left. There's the negative 1.0. Now, the u prime, again, is the speed of the object as seen by the non-reference. So this would be the snowball. So what would the snowball see? Well, first of all, the snowball would see the boy coming towards. Okay, so there's negative. And it would be closing the gap at 2.5. And remember that the v is the speed of the two observers as measured from the reference observer, or the stationary observer. So the v would be the speed between the girl and the snowball. And it would be, what is the speed of the non-reference, so snowball, as seen by the reference, that would be the girl, and so it's moving away to the right, so it's positive, and it would be 1.5. And so we could set it up that way. So again, we don't have to make a big deal about which one is the reference observer, which one is moving, which one is stationary, which one is the object. In fact, this is probably the weirdest of all of them. I mean, because number one, I don't think you would naturally pick the boy as being the object that's moving. And likewise, I don't think you would naturally pick the girl as being the stationary observer. But if we do that, this is the equation. Let's see if it works, or these are the values, and let's see if it works into the equation. And so I'll call this scenario number 3, does it still work, using the above equation. The u is a negative 1.0. Excuse me. And then the v is a plus 1.5. The u prime is a negative 2.5. The denominator is 1 plus v, 1.5, times u prime, negative 2.5, divided by a really large number again. And then in the top, you can see you have your negative 1.0. And in the bottom, you have something approximately 1. It looks like it's 0.9999999, which again is negative 1.0. And sure enough, it does match. And that's my point. That's the point of this whole video here, is trying to emphasize to you that it does not matter which one you pick for your reference or your non-moving, which one is your moving observer, and then, of course, the speed between the two, and then which one is the object. It doesn't matter. They will all work. So I'm going to leave you with 2 pieces of advice. One piece, and sometimes they conflict, and that's what I want to emphasize. One piece would be to say, pick the most natural one, you know, which is focused on. And I think in this case, the most natural one is we've got 2 observers looking at a snowball. And so I would pick the object to be the snowball. You don't have to do that, as I'm trying to emphasize, but it seems like the most natural case. And then, which one's stationary? If there is a natural case, put yourself in that position. Usually the one like standing on Earth and, you know, something else is moving relative to the Earth. That seems to be the more natural. But sometimes these problems just have 2 spaceships, and you're like, well, okay, which one's stationary? So just remember it doesn't matter. So in one sense, I would say pick the one that is conceptually more obvious to you. That would make it easier for you to write down which one is the u, which one is the u prime, and which one is the v. Now, with that being said, let me give you another piece of advice that might conflict with that first one. And that is, this equation. Look at this equation for a second. This equation is set up that if you know any two, you can find the third. And the easiest calculation is done when you know the v and the u prime, because you would put them into here and get the u. If you did not know the u prime or the v, since there is a v in top and bottom or a u prime top and bottom, you have to do a lot of algebra to solve for the unknown. And so algebraically, I would say the best way to do a problem is to realize that in a given problem, you know two speeds and there's a third one you don't know. Make that third one to be u. Remember, u is the speed between the reference observer and the object. And that way, you can figure out the other two values, the v and the u prime, and because of that, it's a quick algebraic calculation. You just a plug and chug to get the u. And so maybe that's stronger than the conceptual one. And those could be in conflict with each other. And that's really what I wanted to emphasize, is that careful on your definitions of u prime. You can pick either one to be it. But if you have troubles conceptually visualizing them, I would go with the easy one and then the harder algebra. But on the other hand, if you have no problem conceptually visualizing it, I would set it up so that the unknown in the problem is the u. That would be the velocity between the reference and the object. And then hopefully you know the velocity of the object by the non-reference observer or moving observer, and also to know the velocity between the two observers. So you know those two, which you would just plug in and get that one. All right, well, hope this video helped somebody. Take care.